Amazing people. What I want to do now is I want to explain how you can have different types of angles in relation to parallel lines. Now, one of the first aspects of this is I want us to consider what happens when we've got a line that passes through some parallel lines or any other lines for that matter. Now, what I've got here is I've got two sets of lines lined out. One are parallel, and we can tell they're parallel because they've got these arrow symbols here, which represent that they are parallel. The other ones don't have that, so they're not parallel, and you can see that they're kind of moving closer, closer together as we progress along. Now, what I want to do is analyze where we have this special line that crosses two or more lines. So in this case here of the parallel lines, if I was to draw this red line here, and even in the other ones, this red line over here, this red line here is what is called a transversal. So the transversal is a line that crosses two or more other lines. Now, the idea of transverse means to cross or crossing. And so in this case here, when we have it occur, this is called a transversal when it's crossing these other lines here. Okay, now here, what I want to do is I want to talk about the special properties of a transversal and parallel lines. Now you can see I've got these parallel lines, which I've indicated in blue, and then I've also got the red line here, which is a transversal. Now, as a result of this, we have all these different angles that are formed. So I'm going to label them 1, 2, 3, 4, 5, 6, 7, 8, because there's 8 of them. So the first one would be here, got a second one here, a third, a fourth, fifth, a sixth, a seventh, and an eighth. And so we've got these 8 angles, which we now have as a result of the parallel lines and the transversal. But there's special properties which relate from this. So what I want to do is I want to start to talk through each of these properties. Okay, now the 3 special properties here are called corresponding angles, alternate angles, and co-interior angles. I'm going to go through each of these here carefully to explain them. The first of these is corresponding angles. So corresponding angles is where you've got 2 angles which are the same size, and what they normally look like is they are in matching positions according to the transversal and the parallel lines. So in the case here, I have some corresponding angles which could be located here, which I'm highlighting in green, and this angle here would be a matching corresponding angle. Okay, so that would be one example. I could also have another example where I've got this shape here and this one here. Those 2 angles there, because they're in the same similar position in relation to the parallel lines and the transversal, they would be considered corresponding. I can also have some other ones as well on the other side. So I could have this one up the top here, along with this one here. Okay, those 2 lines, angles there are corresponding. And likewise, if I went the ones just below that, I could have that angle there and that angle there as a result. Okay, so these are examples of corresponding angles. Now, one key aspect of this is when we label angles, often we can give them a symbol. Often we do tend to use a letter, but we can also use what's called a Greek letter, sometimes called theta. As well when representing angles. So in this case here, I could use theta for both of these as they are the same size. In this case here, I won't do that. I'll just use the letter M. Okay, and these would represent the corresponding angles. Now, one key thing I'd like to point out here is if we look at this here, we think about the shapes that we are tracing out here. We've got this angle here and then down. That represents the first angle of M. The second angle of M is across and then down like this. That represents the second angle of M. And you might notice from the green highlight, which I've just done, in this case, it's kind of back to front, but it kind of looks like an F. So a good way to remember corresponding angles is by looking for the shape you get. If it looks like an F shape, then there's a good chance that you have corresponding angles. Now, the next set of the special properties we have is the alternate angles. Now, in the case of the alternate angles, in this case here, they're a little bit different. So there are 2 angles which are between lines, but they're on opposite sides of the transversal. So in this case here, if I was to pick one of them, I'm going to choose this one here. Okay, it needs to be on the opposite side of the transversal, which means I need to go from this side to the other side. And so as a result of that, that means this angle here would be considered the alternate angle in this situation. Now, if I go back, I can also consider it if it's more widely spread and a bigger angle. So if I was to take this angle here, that angle there matches up to this angle here. So these 2 angles would be considered to be alternate angles here. Okay, so in this case here, let's label them. Let's label them K, so we can have it. And so let's think about the shape that we can have here when we have these as well. So as we trace over where the angles are appearing, so the first angle K here, then I need to go down the transversal. And then if I continue to get the other angle of K, you'll notice that kind of zigzag shape that it gets there. Now in this case, it kind of gives us a Z shape. And so the Z shape is really a good important way to remember when you have alternate angles. Okay, now after the first 2 properties that we've had there, where we have the same sized angles, Co-interior angles are a little bit different, but the idea of interior is what's defining them here. Now, the good thing about this starts with a C for co, and what we're looking for is kind of going to look a little bit like that as well. So in the case here, I always consider this to be a little bit like a cave. And so when we've got two angles which are co-interior, what we're looking for here is for the sum of those two angles to add up to 180 degrees. So they would be described as supplementary angles as well. Okay, so as we look about this here, let's draw them onto what we've got. Okay, so as we find these angles, they could be these two angles here. As you can see, they're both on the same side of the transverse and in between the parallel lines. Alternatively, if we want, we could also put them on the other side as well. So it would be these two angles here. Now in this case here, I'm going to give them a label. I'm going to call the little one X and the other one Y. Now, because we're dealing with parallel lines here, they have a special property, and that special part is they're going to add up to 180 degrees. So angle X, whatever that might be, plus angle Y is going to equal 180 degrees because they are inside parallel lines. Okay, now you will notice here as a result, if we think about this, as we trace out the lines that we need to use in order to understand where these are, you can see here that I'm getting that kind of C shape or that cave-like shape to it. Okay, so when you have co-interior angles, what I want you to do is I want you to look for the kind of square C shape, or you could say that it's like a cave. There's another way of thinking about it.